Alright, this is concept 29, absolute value inequalities. The absolute value of x written as, and it's the two bars with the value inside, written as absolute value of x, is the distance of x from 0. Okay, so absolute values shouldn't be new, but we're going to review them anyway. For example, since both -2 and 2 are 2 units from 0. What I mean by this is, here's my number line, here's 0 in the center. Here's -2, so this is -2, and that's +2. Okay, both of these, if I count how far away are they from 0, okay, they are both 2 units away from 0. So we have that the absolute value of -2 is equal to the absolute value of 2, which is equal to 2 units away from 0. Okay, again, absolute value of whatever number is the distance that it is from 0. So if I had absolute value of 5, for example, so 3, 4, 5, here we are. Okay, I am 5 units away from 0. If I was at -5, I would also be right here, if I was at -5, I would also be 5 units away from 0. So some examples. What is the absolute value of 3? Well, how far am I from 0? Right, that would be 3 units. If I'm at -4, the absolute value of -4 means how far am I from 0? It would be equivalent to the absolute value of 4, which is just 4. Number 3. Okay, so I have 2 times the absolute value of -1. This is equal to 2 absolute value, right? -1 is equivalent to 1. How far am I from 0? Well, -1 is 1 unit away from 0. So 2 times the absolute value of 1, which is just 2 times 1, which is equal to 2. Okay? And you can add the little descriptions here at the bottom just to help you reference later, right? 3 units away from 0. This is well, that's right, -4 is 4 units away from 0, and then this one would be that -1 is 1 unit away from 0, multiplied by 2, and that gives you 2. So then what about absolute value inequality? So we've been doing this, right? We did inequalities in our previous concept. So when you have them, when you have these absolute values now with inequalities, what you're going to do is, okay, just like we said, the value, right, -4, for example, a negative value is the same as a positive value because they are both equivalent in distance away from 0. You can say, okay, you can say that the same thing, x, whether it's the positive or the negative, whatever it is, okay, it is the same amount of units away from 3. So what does this look like? Absolute value of x less than 3. You're going to say that -3 is less than x, which is less than 3, because again, it's the equivalent amount of units away. So in your number line, I have, here's -3, there's 3, so I have open circles, right, because it's less than, so open circle, and then my inequality, or what solutions do I have? It's everything shaded in between. And that's all there is to it. Here in number 2, I have the absolute value of 2x plus 3 is less than 6. Same idea, okay? So what you have to recall is whatever this expression is, it's the same distance away from 0, which is less than 6. So just like I took here, absolute value of x less than 3, so -3 less than x less than 3, you can do the same thing. So I get -6 less than 2x plus 3 less than 6. So last time, what you have to remember is, right, just take the right side would stay the same sign right here, okay? The left side becomes the negative of whatever you have here, that's here, and then you take whatever's inside the absolute value and you place it in the center. Okay, I did the same thing here. 3, 3, negative 3, negative 3, and then x here. So now I solve for or get x by itself, so I subtract 3 and I get negative 9 is less than 2x less than 3. Whoops, 3, and then I divide by 2, and this is not going to be one of those whole number ones, so I have negative 9 over 2 is less than x, which is less than 3 over 2. You can use your calculator to figure out what these are in decimals so we could be more accurate. Negative 9 over 2, that's 4.5, so this is negative, so alright, this is the same thing, right, as negative 4.5 less than x, which is less than 3 over 2 is 1.5. So that makes it easier to plot. I'm at, let me see, 1, 2, 3, 4, 4.5, so it's right here. Negative 4.5. I have an open circle. Okay, all the way to 1.5 here. Whoops, I forgot to write that. That's 1.5. And then my solution set, or my domain, is everything in between. And again, just think about what this means. If you plug in 0 here, okay, 0, this would cancel, so you get just 3. 3 is greater than negative 6. But 3 is less than 6, so this statement holds. If you plug in, I don't know, if you plug in 1, 2 times 1 is 2, plus 3, you get 5. 5 is greater than negative 6, but 5 is less than 6. So again, the statement holds. Finally, last one here. I have to think, what's different in this case? Here I had the absolute value expression less than the number. In this case here, I have the absolute value greater than that value. Okay, so this does change things. Okay, it doesn't. It's slightly different. So what do you have is you're gonna take 1 just as it is. Okay, take the without the absolute value. So 2x minus 3 is greater than 5. Okay, or so it's an or statement. Okay, 2x minus 3, flip the sign, okay, minus 5. I live close to the freeway, guys, so what you just heard is a car speeding really fast. So that's it. That's how this single expression here breaks up into 2 expressions. So from there you would solve two inequalities. Again, you would plot both of them as well. So I have, add 3 to both sides. I get 2x is greater than 8, and then I'll get x is greater than 4. And I don't flip the sign because I didn't divide by a negative. Here I add 3 to both sides, and I get 2x is less than negative 2. And then I divide by 2, so I get x, and again I divide by positive 2, so I don't change the sign, so x is less than negative 1. So this case is a little different, right? So I have x greater than 4. So if I go here and I plot 4, open circle, okay, then I have x less than negative 1. So open circle here. So let's plot what this means. Well, x is greater than 4, so all values to the right here. Okay, again, x greater than 4. This one says x less than negative 1. So here's negative 1. What's less than negative 1? It would be all those other negative numbers going to the left. So I have something like this. Okay, so what x values make this statement true? Everything less than negative 1, everything greater than 4, but anything in between here will not make this statement true. Okay, so that's all there is to it. And that's concept 29, guys. That wraps it up.